Hello, algebra. So the next and last thing to this graphing unit is line of best fit. Some might call it scatter plots, but it's the same thing, okay? A scatter plot just refers to the graph. A line of best fit refers to how you're going to represent the data on the graph. Now you'll see in this graph here, there's kind of a story problem. There's more to it than just like the XY axis, okay? All of these problems, there's going to be some sort, well, not all of them, but most of them, there's going to be some sort of story behind the problem that you need to analyze and figure out from there. Okay, so the first thing you always have to do is read your problem. Okay, like in here it says the number to the right, or to the right is a scatter plot of data comparing the number of chapters in a textbook to the number of typos found within the book. Answer the following questions based on the graph. Okay. The first thing you always have to do is identify your data and plot it on the graph. Now, for this one, you can see it's already on the graph. That makes it a lot easier, okay? So you won't have to do anything with that. You can see in like the second problem, third problem, fourth problem, it's not always going to be on there, but you can see for this purpose there is, so you're not just waiting for me to plot points, okay? The second thing, even if it's asked somewhere else, okay, you always want to draw your line of best fit. Now, there will be things that, it might say, what is this talking about? Okay, in this case, we would say the number of typos found in each chapter and stuff like that, or for every chapter, okay? But that's not specifically saying what exactly the slope is, okay? The slope needs some sort of number, okay? So first thing, draw the line. Now, a line of best fit is always done so that it best represents the data. Now, in this case, you can kind of see a lot of our numbers here, or a lot of our data here, is lined up already, so it's not going to be that bad, and it'll be pretty easy, okay? So what you want to do is you always want to start somewhere easy, okay? On any given line, you need 2 points. It could be any of these points. It doesn't necessarily need to be any of those points, okay? In this case, it'll probably be easier if it is one of those points. So I'm going to start somewhere easy. It kind of looks like if I had some sort of straight line here, okay, you're not connecting this, so you're not doing something like this where you're connecting all of the dots, okay? You're not doing that, so please don't do that. Okay, you're drawing a line of best fit. So it looks like maybe we could start at the 2. So I could start here as 1 point, okay? You always need a y-intercept. So we'll start there and we'll kind of draw a line going through the middle-ish of all these points. Just pretend my line's perfectly straight. So we have something like this. And then it kind of looks like I touch right here. So I'm going to put my second point there. Now I could have used a point up here. Okay, don't use the point right next to it just because that's not going to represent it. Use something towards the middle-ish. And you always want to use something that's an actual point, which we've talked about before when identifying points on a graph to begin with. Okay, so step A, draw line best fit, done. Okay, now I'm going to draw a couple lines that are not lines of best fit. You don't always need to start at 0, 0. You'll notice sometimes it will, because you notice if I do that, it kind of misses some of the points to the side there. Okay, you'll also notice that if I lost my mouse. Okay, if I start here and draw something like that, that's not good enough. Okay, if I went under all the points, not good enough. If I went over all the points, not good enough. Okay, all of those are not good enough points. Okay, so we need to make sure we're drawing a line that's going to best fit this. Okay, from here, we identify what the slope and what the intercept is. Okay, so to write the equation, remember we have y equals mx plus b. Okay. In this case, our m. Okay, we just need to think how far we went up. So we started at 2 typos and we went up to 6. So we went up 4. And then we went from 0, because we're starting at 0 on the y-axis, and we went right to 4. So we have 4 over 4. Now that makes it pretty easy. It just becomes a 1. Okay. On this, you need to be careful that you're looking at the numbers and not just counting the lines, because the lines don't always represent how far it's actually changing. Okay, and then the intercept here is where we started at, and we started at that positive 2. So my B is 2. And then I'm going to write down my equation, y equals, you can put the 1x, I'll put it for now, plus 2. And that is the answer for B. Okay. At any point you need to pause to write this stuff down, go ahead. The next part says, what does the slope of this line mean in context to the situation? So you don't just name the slope, you say what it means in regards to this. So the slope is 1/1 technically, so that means it's one typo for one chapter. So you would say something along the lines of, there's one typo for each chapter. Okay? And that is our answer. For D here, when it's asking what is the y-intercept of the graph, okay, it's just asking that to go into the next question. Okay, the y-intercept was 2. Okay, so it says, what does the y-intercept mean in context of the situation? Technically, it might not make that much sense, but that means there's 2 typos, okay, before any of the chapters. Okay, so you would say 2 typos at 0 chapters. Okay, 2 typos at 0 chapters. I'll get used to writing this thing again. All right, so again, pause if you need to. We're going to do another one. There's a bunch on here which you can do. I'm going to share this worksheet with you, so you can do them as you see fit for extra practice before the actual practice. Okay, pause if you need to. All right, we're going to jump down to number 4 because number 2, I don't like how it's not necessarily a graph. Same thing with number 3. Okay, there's no lines and stuff, so then you're just estimating even more. Okay, here I know it's not the best graph, but you'll notice that these points are all of a sudden going down instead. Okay, what this is actually called is a correlation. Now, number 1, it was very simple. These lines made basically a line. Okay, you would say that this has a positive correlation because the points are generally going up. Well, all the points are going up. It basically made a line. Okay, so that one should be pretty obvious. When we talk about a correlation or like a relationship, it's just positive or negative. Okay, so in this case, it says to the right is a scatter plot of the data comparing the age of a car in years to the value of the car in thousands. Okay, obviously it's thousands of dollars. And it says answer the following questions. Well, in this case, it's going down, and that makes sense because the longer you have the car, the less it's going to cost someone else to buy it from you. Okay, or the less it would be worth. Okay, if you had a car for 1 year, it would still be worth a good amount. If you had it for 10 years, it wouldn't be worth nearly as much as it was when you first bought it. Okay, so in this case, there's going to be different lines that you could start at. Now, someone might draw a line here. Okay, that's not too bad. Someone might draw a line starting at the same point. They might go a little bit lower here. That's not the best. Someone might go right between that. Okay, someone might start at 10. Someone might start at 8. All of those are not too bad. Okay, what I would say is start at something that looks like it's going to go through the middle of the points. You don't want to go under them or over them. You want to try to go through the middle. So it looks like 9 or 10. I wouldn't start at 8 because 8, then you're kind of coming like across a lot of it to get to the end. So I would start at 9 or 10. I'm going to start at 9. Okay, so my first point's at 9. And I'm just going to go through, again, just the general middle. That's not the best line ever. Okay, you're going to go through, in general, the middle of these points. Okay, so it's going to look something like that. Okay, that will be good enough. Mine should have kind of kept going downward a little bit, but my line's not the best. So I have a point here, and that looks like I kind of have a point. I know the graph is bad, but it looks like I have a point here. Okay, now if you go directly through a point that's already there, that makes it easy. Okay, because you can use that point, especially if you're given the data first. Okay, but we're going to use these 2 points. So we drew the line. Now we need to write the equation. So my slope, okay, since it's going down here, it has a negative correlation. That means my slope's going to be negative. So I went down from 9 to 6. So that's going to be -3. Now what you need to keep in mind, it's not just a 3. Remember, this is 3,000. Okay, so we have 3,000. It's going down by 3,000. And then it went from 0 to 6. Okay, that's going to make our life a little bit easier. And then we just need to simplify that. Okay, 6 going in here, we're going to get a negative 500 for our slope. And then we started at the 9. Okay, so my B here, leave myself some room. My B is going to be 9,000. Okay, since we started at the 9, it's 9,000. So then we write our equation, y equals negative 500 x, and then we have plus 900. Now here's, or 9,000. Here's a hint. Your intercept is always going to be positive. Okay, you notice we're only talking about the first quadrant. Your slope could be positive or negative. In this case, it's negative. Okay, but your intercept will always be positive. Okay, from there we answer the same question. What does the slope mean of the line mean in the context of the situation? Okay, so it's going down. So that means you need to describe it in terms of it's going down. Don't just say $500 per year. You need to say it's decreasing. Okay, you always need to say it when it's decreasing, because then it separates the difference between you saying like you earned $500 each year to the price is going down. So we would say the price or the value, let's say value decreases. Okay, so that's telling us that it's going down. Value decreases, $500 per, that's not how you spell per. I was trying to spell year ahead of time. Per year. Okay, value decreases $500 per year. That describes the negative 500 for the slope. And then we go to the y-intercept. Okay, it started at 9,000. So we'll write 9,000. And then it says, what does the y-intercept mean? Well, in this case, it just means the cost of the car was 9,000. Okay, so you say the car cost $9,000. Okay, and that's it. If you want to say it cost $9,000 when you bought it, okay, but that would be perfectly acceptable for now. Okay, pause if you need to. Otherwise, that is it. This is a bit different because you need to understand the concept, but you still need slope, you still need intercept, and you still need to know how to find slope and all of that stuff and understand the whole graphing the line. Okay, so that's it. This is the last part of the unit. We will have a practice for this, and I will see you next time.